And so what I wanted to do was I just wanted to introduce you to the max and the min of a quadratic, okay? Now, if you look at my function right here, here is the function, and here is the graph for that exact function, right? Now, all a max or min is as you look at the graph, okay, you can see that this graph's going up forever. There ought to even be an arrow right here, shouldn't there? The graph's going up forever. So, Aaron, it doesn't have a maximum, right? Because the maximum would be infinity, but infinity's not a number because it just keeps going up forever, doesn't it? But where is the lowest point on the graph? Right here, isn't it? Isn't this the lowest point? What is that lowest point is also known as the what? Vertex. Okay, so in parabolas, your max or your min will always occur at the what? At the vertex. Your max and min will always occur at the vertex. So you can tell right here, that's your minimum, isn't it? And that is at -5. And so your minimum in this case is -5. I'm sorry, not -5. It's at, what's the x value? 2 over 2 and down 5. So your minimum is at the point 2, -5. That's the location of your minimum. And does this one have a maximum? You could say it either doesn't have a max or the max is infinity, right? So let's look at this one. Right here I've got this function, and this is the graph of the function right here. In this case, the minimum is going to be -infinity, right? But there's a maximum. The maximum falls somewhere around right here, doesn't it? Now, what did we say? On a parabola, the max and min always occurs at the what? Vertex. So where is that vertex? It looks like it's at 1.5 and up 4.75. Okay, you see that it goes right. Here's 1.25, and that's 1.5, isn't it? And then up 1. This is 1.25, 1.5, 1.75, and 2. And 3 and 4.25, 4.5, 4.75, right? So there's a maximum in this case. There's a maximum, and it's at the point 1.5 and 4.75. Now, we calculated the max by looking at the graph, but I could have done -b over 2a on this function and calculated the vertex the same way, right? So when we're dealing with parabolas, the max and min will always occur at the vertex. Now, in this case, the graph goes up forever, doesn't it? So the maximum is going to be infinity, right? Because it goes up forever. But it does have a minimum right here, doesn't it? There's our minimum at the vertex. Now, our function is in what form? Vertex form, which makes it real easy to tell the vertex. What is the vertex? 2, 1, right? You take what will make inside the parentheses 0, and that's 2. And then you take whatever's out here, and that goes as the y value. So in this case, right here is your minimum, and we have a minimum at the point 2, 1. Right? This is the lowest point on the graph. Okay, so I've got two functions on the board, and here's what I want to know. On this function, will I have a maximum or a minimum? And I want you to tell me without graphing it. And on this function, will I have a maximum or a minimum? Well, can you think of how you might know whether this has a max or min? Very good. The leading coefficient is 2, right? Which is positive. Since the leading coefficient in this function is positive, we know this is going to open which way? Upward, right? And since it opens upward, it's going to have a what? A minimum. Okay? On this one, the second function, the leading coefficient is what? Negative, which tells me that the function opens what? Downward. And so on the second one, I know I'm going to have a maximum. Okay? And now if I wanted to know the minimum of this first one, I'd just calculate the vertex, right? And if I wanted to know where this maximum happens on this one, I'd just calculate the what? Vertex, because the minimum and the maximum always happens at the vertex, right?